So now we're going to talk about why it's important to balance chemical equations, aside from the fact that I told you needed to, and relate that to reaction stoichiometry. Now, I really like this slide, and to be honest, I probably get my little pointer again. I really should have a great big fat star on this slide because I think this is a great summary slide as to the importance of why we balance chemical equations, as well as giving you a reminder of how to do stoichiometry with regards to a balanced chemical equation. So in the previous video, we talked about the parts of a chemical equation. We said we needed to balance them by using coefficients because atoms can't just appear or disappear in a chemical equation. Those coefficients in a balanced chemical equation, we can use that on a molecular or molecule basis. Kind of talked about that in chapter 2. I could say for every 2 molecules of hydrogen and 1 molecule of oxygen, if there's no coefficient out front, it's an assumed 1, I'm going to get 2 molecules of water. But aside from stating that on a molecular level, I can also do that on a chemist's favorite unit, mole level. If I have 2 moles of hydrogen gas and 1 mole of oxygen gas, that can combine to give me 2 moles of water, liquid water. Why is that so exciting to chemists, being able to do that on a mole level? Well, that's kind of exciting because once we know moles of reactant or product, we can easily convert that into grams using that substance's molar mass. And grams, hey, that's something that can be easily weighed out or determined in the lab. So now we have a way where we can have chemical equations and make predictions based on how much product to receive using stoichiometry. And the way we do that is from the coefficients of the balanced chemical equation. So in many of the problems on the worksheet and some that we're going to work here in subsequent videos, in those problems you're going to be given a chemical equation and reactant amounts and asked to determine product amounts, and you will need to do sort of this 3-step dance, converting your grams of substance to moles of substance using the molar mass of that particular substance, going from moles of what you're given to moles of what you're looking for using coefficients of the balanced equation, and then going from moles of that substance to grams of your substance by the molar mass of that substance. So that 3-step dance is one we're going to be doing in subsequent problems. And like I said, I really like this slide because I think it's a great summary slide of that concept. We're going to do several problems using that. But before we do that, there's one more concept we need to introduce, which I will do that in the next video, and that's the concept of limiting reactant.